The War of Currents was a series of events surrounding the introduction of competing electric power transmission systems in the late 1880s and early 1890s, including commercial competition, a debate over electrical safety, and a media propaganda campaign that grew out of it, with the main players being the direct current-based Edison Electric Light Company and the alternating current-based Westinghouse Electric Company. It took place during the introduction and rapid expansion of the alternating current standard and its eventual adoption over the direct current distribution system. Three aspects have been conflated together into the war: open competition involving large electric companies and their developing systems, a general fear in the public's mind of death by accidental electrocution from high-voltage AC leading to a debate over its safety and regulation, and the debate and behind-the-scene maneuvers associated with the introduction of the electric chair. The introduction of large-scale outdoor arc lighting systems in the late 1870s, some of them powered by high-voltage alternating current, was followed in 1882 by Thomas Edison's low-voltage DC electric distribution utility, designed for indoor business and residential use as an alternative to gas and oil-based lighting. In 1886, George Westinghouse began building an alternating current system that used a transformer to step up voltage for long-distance transmission, and then stepped it back down for indoor lighting. A more efficient and less expensive system that directly competed for the market the Edison system was designed to serve. As many other AC companies joined in and the use of AC spread rapidly, Edison's company made claims in early 1888 that alternating current was hazardous and inferior to the patented direct current system. In the spring of 1888, a media furor arose over a series of deaths caused by pole-mounted high-voltage AC lines in New York City and around the country, attributed to the greed and callousness of the local AC-based lighting companies. In June of that year, a New York electrical engineer named Harold P. Braun came to prominence as an opponent of the use of alternating current, claiming the AC-based lighting companies were putting the public at risk using high voltages and installing it in a slipshod manner. Braun's campaign immediately gained the assistance of Edison and his company, aiding Braun in the public electrocution of animals with AC, trying to prove Braun's claim that AC was more dangerous than DC. Historians noted, and documents from the period seem to show, that there grew to be collusion between Edison's company and Braun in their parallel attempts to limit the use of AC, assisting Braun's attempt to push through legislation to control and severely limit AC installations and voltages, providing technical assistance in Braun's tests to show AC would be the best current to power the new electric chair, and colluding with Braun and Westinghouse's chief AC rival, the Thomson-Houston Electric Company, to make sure the first electric chair was powered by a Westinghouse AC generator. This was a period of industrial consolidation, and by 1890 over a dozen electric companies had merged down to three: Edison, Thomson-Houston, and Westinghouse. By the early 1890s, the latter two were generating profits far in advance of the DC-based Edison Company. During this period, Thomas Edison left the electric power business and the company he founded was beginning to add AC technology to its system. Edison Electric's institutional opposition to alternating current came to an end in 1892 when they merged with what had become their biggest competitor, the Thomson-Houston Company, a merger that put the managers of Thomson-Houston in control of the new company, now called General Electric. The merger of the Edison Company with Thomson-Houston created a company that now controlled three-quarters of the U.S. electrical business. Westinghouse won the bid to supply electrical power for the World's Columbian Exposition in 1893 and would go on that year to win the first contract at Niagara Falls. Their lead in the field quickly diminished, with later contracts being split with General Electric. There were several technical factors that drove the adoption of alternating current over direct current. The direct current system generated and distributed electrical power at the same voltage as used by the customer's lamps and motors. This required the use of large, costly distribution wires and forced generating plants to be near the loads. With the development of a practical transformer, alternating current power could be sent long distances over relatively small wires at a conveniently high voltage, then reduced in voltage to that used by a customer. Alternating current generating stations could be larger, more efficient, and the distribution wires were relatively less costly. The lower cost of AC power distribution prevailed, though DC systems persisted in some urban areas throughout the 20th century. While DC power is not used generally for the transmission of energy from power plants into homes as Edison and others intended, it is still common when distances are small. It is used widely in all modern electronic devices such as computers, telephones, and automotive systems.